Let's learn how to graph a parabola. For example, let's sketch the graph of this quadratic function here. Well, the graph of a quadratic function is what we call a parabola. And an important point on a parabola is called the vertex. It is the point where the parabola turns around. So this would be called the vertex here. Or this would be considered the vertex. And the vertex is also the only point on the parabola that lies on what we call the axis of symmetry. This is the line about which the parabola is symmetric. That is, the graph is a mirror image on either side of this axis of symmetry. Now, in general, we can graph a parabola by plotting its vertex and a few points on either side of it. But how do we find the vertex? Well, we have the following vertex form for the equation of a quadratic function. F of x is equal to a times x minus h squared plus k, where hk is the vertex. And if a is greater than 0, then the parabola will open upward like this second figure here. And if a is less than 0, then the parabola will open downward like the first figure. But how do we get a quadratic function that's in standard form like ours here into vertex form? Well, we complete the square. So let's do that. We have f of x is equal to x squared minus 8x plus 15. Now remember that the first step in completing the square is to make sure that the coefficient of the square term is 1, which it is here. And then we take 1/2 the coefficient of x, which in this case is negative 8, which gives us negative 4. And then we square this number. So negative 4 squared is 16. And then we add and subtract this number. That is, this is equal to x squared minus 8x plus 16 minus 16, and then we still have the plus 15. Now these first three terms will form a perfect square, namely x minus 4 quantity squared. And then negative 16 plus 15 is negative 1. And so we've put our function into vertex form. So we have f of x is equal to x minus 4 squared minus 1. And therefore our a is equal to 1, our h is equal to 4, and our k is equal to negative 1. And since a here is greater than 0, our parabola will be opening upward, and our vertex is at 4, negative 1. So let's plot our vertex. Let's say that this is the y-axis, and this is the x-axis. And let's say that this is 1, 2, 3, 4, and that this is negative 1. Then our vertex is here at 4, negative 1. Now let's find some other points on our parabola. So x and y. When x is equal to 2, for example, we can plug that value into this form here, and we get that y is equal to what? 2 minus 4 is negative 2, negative 2 squared is 4, and 4 minus 1 is 3. So when x is 2, y will be 3. What about when x is 3? We get 3 minus 4, which is negative 1, quantity squared, which is 1, and then 1 minus 1 is 0. So when x is 3, y will be 0. And when x is equal to 5, we have 5 minus 4 is 1, 1 squared is 1, and 1 minus 1 is 0. And then when x is equal to 6, we have 6 minus 4, which is 2. 2 squared is 4, and 4 minus 1 is 3. So let's plot these points. So this is 1, 2, 3. So 2, 3 will be here. 3, 0 will be here. 5, 0 will be here. And 6, 3 will be here. And our parabola will look like this. So this is the sketch that we're looking for. However, let's notice a few things. Let's draw our line of symmetry here. That is, x is equal to 4. And doing this, we can see that this graph is symmetric about that axis, or the mirror image on either side of it. And so looking back over here in the table, we really only needed to determine these 2 points here. That is this point over here on the graph, 2, 3, and this point here, 3, 0. Because we get the other 2 by symmetry, don't we? 5, 0, and 6, 3. So using this axis of symmetry is very useful when sketching parabolas. Thank you, and we'll see you next time.